So dear students, so today I'll be discussing wave optic entrance. So yeah, little bit tricky this particular session will be. I'll try to explain everything in a very easy way for you guys as possible. So let's take the first question as you can see here. Yeah, two light waves, correct, of the intensities I1 and I2 having same frequency pass through the medium at a time in same direction. The sum of minimum and maximum intensities is how much? So this is our question. For a better bandwidth, I'm just offering my video. Yeah. So because it's a distraction for me also. Let's just see my face again on the screen. So coming to this, let me. Any idea or you guys know how to do this? Or you need my help in this? Let me know. No idea. Okay, perfect. So that's the reason I told you this kind of questions are a little bit tricky. Correct? See, for example, how to approach these questions is any light, correct? Any wave, let it be any wave, will have what? An amplitude, height. Wave. I'm talking about waves. Correct. Any wave will have what? Height, the amplitude. Correct. Yes. And then there will be something called maximum height, something will have. Yes. For example, if I take this particular curve, it will have a minimum amplitude, minimum height, as well as it will have a maximum height. Two things it will be there. Correct. Yes. So how many light waves are there in this? Two light waves are there in our problem. Correct? Yes. So with this understanding, we will start the approach for this particular question. Two light waves of intensities I1 and I2. Correct? So obviously light wave will have intensity. So I'll take A1 as the amplitude of the first light wave, and A2 as that of the second light wave. Okay. Correct? Yeah. So after the interference, correct? What they're telling? They hang same frequency, pass through same medium at a time, same and interfere. So after interference, there can be two possibilities. One is maximum intensity. This is after interference of the two lights. Maximum intensity. Correct? That is my I maximum. This is basically what? My amplitude 1 plus amplitude 2 the whole square. A1 plus A2 the whole square. Then it can be minimum also. Minimum intensity. That is my I minimum. That is nothing but what? A1 minus A2 the whole square. Now I have to find what? Sum of minimum and maximum. Sum of minimum maximum. In the sense I have to add what? I have to add I max plus I minimum. Correct? So this is all whole square. All whole square basically. Correct? Yeah. So if I want to expand this, this will be A1 square plus A2 square plus 2A1 A2. This is A1 square plus A2 square minus 2A1 A2. So what is getting cancelled? 2A1 A2 is getting cancelled. So I can take 2 outside and directly write what? A1 square plus A2 square. 2A1 square plus A2 square. Is this step understood by everyone or not? I just added I max and I min. Is this step understood by everyone? Only thing is that I just after that 2AB is there, right? 2AB and minus 2AB, I just added, I just cancelled it out. That's the only thing which I did. Okay, yeah. And then intensity is what? I1 and I2. Correct. So what I can replace A1 as, what is my amplitude 1 square basically? What is my A1 square? That is basically my I1. And what is my A2 square? I2. That is my intensity respectively of the amplitude. So I can just replace it with what? 2 into I1 plus I2. So option B is the answer for this. Option B is the answer. It's a simple question. But again, kind of complicated. So I just cleared it out. Second one. A single slit is illuminated by a light of wavelength 6000 Armstrong. The slit width is how much? 0.1 centimeter, and the screen is placed 1 meter away. The angular position of 10th minimum in radian is how much? So how much is 1 Armstrong, guys? Let me know in chat option. Yes, 10 power minus 10. Correct. So can everyone try, or you need my help in this? But if I'm converting into centimeter, but anyway, everything will take it as meter only because that is standard unit. Okay. So does everyone know how to do this question is my question. Or anyone need help in this question to do? What is slit width? 0.1. 0.1 centimeter. So 0.1 centimeter is basically what? 10 power minus 3 meter. How many of you have doubt in this? I'll just call the names and I'll ask. Kanaga, what about you? Do you have doubt in 0.1 centimeter to 10 power minus 3 meter? Ali, Aman and Anup? I think already Aman has sent me the answer also. Yes. So Aman, can you just share the working in my WhatsApp? Just send a pic to me. Those who have done it, just send a pic to me neatly in my WhatsApp. I can check it out. How many if you don't know this thing, let me know. Okay. No, 1 second. I'm getting some no, sir. Okay, fine. So, no. First thing is, see guys, 1 centimeter is basically what? 1 by 100 meter. Correct? Or else 1 meter is equal to what? 100 centimeter. Correct? So 1 centimeter is what? This 100 will go this side. So it will become by 100. This 100 will go down, not to the top, by 100. So that is basically what? 10 power minus 2 meter. Correct? Now it is 0.1 centimeter. 0.1 centimeter is equal to what? To meter. Again, I have to divide by one more 10. Correct? 1 by 10 is only 0.1. So 10 power minus 2 and by 10 power by 10. Correct? So basically it is what? 10 power minus 3. So that's how I get 10 power minus 3 meter. And this is 6,000 Armstrong. That is 6,000 into 10 power minus 10. 6,000 10 power minus 10. What is the formula which I'll use here? Formula is very simple. Theta is equal to n lambda by d. My d is nothing but 0.1 centimeter is 10 power minus 3. What is n? It is 10th. Lambda. Lambda is what? 6,000 Armstrong. So 6,000 into 10 power minus 10. divided by d. What is my d? 10 power minus 3. Correct? Yeah. So if this minus 3 will go to top, what will happen? Here also 10 is there. Correct? And how many zeros? 3 0. 3, 4 zeros are here. And plus 3, 7 zeros. So obviously I can mark option B as answer. 6 into 10 power minus 3. Is it clear for everyone now? This question? Theta is equal to n lambda by direct substitution I had to do. That's all. Direct substitution I had to do. Yeah. If you're not clear, I'll help you out with the same. Okay. Don't worry. Next one. To observe, for this particular question, just remember my elimination technique. Whenever I got theory, just remember my elimination technique. To observe the diffraction size of the obstacle should be lambda by 2, where lambda is a wavelength. Okay, again, eliminate everything. Should be of the order of the wavelength, has no relation with the wavelength. See, first of all, what is diffraction? We have to know. How many of you don't know what is diffraction? Please let me know in the chat. Okay. See, diffraction is nothing but bending of light. For example, if you're sitting in a chair, correct? And there's a tube light. Just observe the room. Everywhere is the light same? No. Under the chair, the light is not same. Under the table, the light is not same. Correct? Under the chair, under the light, it is not same. Correct? So every light has got what? A different wavelength. So I'm already getting the answers now. Yeah. Aman has given me the correct answer. So again, coming to my question here, eliminating. So option C is wrong. Has no relation to wavelength. Size of obstacle should be much larger than wavelength. No, nothing like that. Diffraction can be observed anywhere. Under the table also we can observe, and under the chair also. It's size of the object or something is not at all a big thing. Option is what should be lambda by 2. Nowhere we have studied that it should be lambda by 2. No condition is there. So only answer is what? Option B. Okay, option B is the right answer for this. Strictly by elimination technique. Next one. I think this is something Young's double slit experiment. If you don't know this thing, let me know now only in the chat. Read the question and let me know. If anyone need my help, please let me know in the fourth question. Okay, so Yeah, one student has responded to me. So better, I will open one thing now. I think you can see the screen properly here. Yes. Can you see, everyone can see the screen properly here? Yes. See, for the path difference at O, correct? The path difference at O, first thing. What is the minima should be? The minima should be, I'll write down here. The minima should be what? 2n minus 1 into lambda by 2. Correct? This is our thing. Now, if I take the distance here, what is the first distance? S1O. Correct? What is second distance? S2O. These all things are there in the question D. The distance between what? The slit and the wall. And this is the slit distance, pi. Now, according to our condition, what is it basically? This S2O is there, no? This S2O, S2, slit 2 and O. Yes, so that should be what? Minus S1 and O. Slit 2O minus S1 O respectively. I'll write down here S2O minus S1O is equal to what? This is equal to my minima. What is my minima? I'll write down S2O minus S1O is equal to 2n minus 1 into lambda by 2. And what is my S2O minus S1O? That is basically, what is my S2O? We all done a derivation, correct? Root of d square plus d square minus, it's just taking the Pythagoras, minus d. S1O is what? S1O, what is the distance? D only. Correct? S2O, I will be taking the Pythagoras thing. Yes, root of d square plus d square minus d is equal to what? 2n minus 1 into lambda by 2. Now, what is d square? 12 square plus 5 square, that is root 169. Minus, what is d12 is equal to 2n minus 1 into lambda by 2. So, root 169 is 13. 13 minus 12 is equal to 2n minus 1 into lambda by 2. Correct? So, if I take n is equal to 1, then what will happen? 13 minus 12 value is 1. 1 is equal to what? 2 minus 1 into lambda by 2. So, what is my lambda value for the minima? 2. So, the answer is 2 centimeter. So, the answer is what? 2 centimeter for this particular question. Is it clear? I think everyone can note down it or take a screenshot of the same. Once you've done this, let me know. So the answer is option A. Answer is option A. Has everyone taken a screenshot of this particular question? Yeah. Or else I'll share it to you later. Next one. Find the half angular width of the central bright maximum in the Fraunhofer diffraction pattern of a slit width 12 into 10 power minus 5 centimeter when the slit is limited by a monochromatic light of wavelength 6000 Armstrong. Yes. So we all know what is my sine theta? Lambda by A. For this thing, sine theta is what? Lambda by A. And what is my theta? The half angular width. This is nothing but my theta. Correct? So what is my lambda given? Slit of width 12 into 10 power minus 5. And what is my lambda? 6000 Armstrong. So 6000 into 10 power minus 10 divided by what is the value? 12 into 10 power minus 5. So I just do a simple calculation and I'll be getting the answer. So 6, I can directly, if I want, I can 10 power 5 will go to top. So this will become on the top 10 power. So those all things will get cancelled here. 10 power minus 5, and this will become what? 6000 is here, right? Yes. And don't forget that this is in centimeter. So multiply by 10 power minus 2. 1 centimeter is equal to 1 meter is equal to 100 centimeter. So 1 centimeter is equal to 10 power minus 2 meter. So multiply by minus 2. So I can cancel all of these things, even a 3 and here. So 1 by 2 sine theta is what I'll be getting? 0.5. Correct? What value of this will be getting 0.5? I know that sine 30 is 1 by 2. That is 0.5. So instead of 0.5, I'll put what sine theta is equal to sine 30. So I'll get theta is equal to 30 degree. That's it. Option C is the answer. Option C is the answer for this. Okay. So with this, let me go to the next question. If the two slits in the Young's experiment are 0.4 millimeter apart and fringe width on the screen 200 centimeter away is 2 millimeter, the wavelength of the light illuminating the slit is how much? Sixth one. This is a traditional thing. I think you know what is fringe width. The moment you see fringe width, what is fringe width? Beta. Beta is equal to lambda d by d. This already you know it better than me. Correct? Now what I have to find? I have to find the wavelength. Lambda I have to find. So what is my lambda? Beta d by d. That's all. Fringe width is given. Correct? Yes. What is the fringe width? 200 centimeter. I told you 1 meter is equal to 100 centimeters. So this I can write as 2 meter. Then 0.4 millimeter. So 1 meter is equal to 10 power minus 3. Correct? Millimeter. Sorry, not 10 power minus 10 cube. 10 power 3. So 1 millimeter is equal to 10 power minus. So 0.4 into 10 power minus 3. Correct? And what is my beta? On a screen 200 centimeters away is 2 millimeter. So this is my D. My D is what? My D is, capital D is 2 meter. And what is my beta? 2 millimeter. This is my beta is 2 millimeter is 2 into 10 power minus 3 meter. So if I substitute beta, D and D, I'll be getting the answer. So my beta value is 2 into 10 power minus 3. And what is my small d value? 0.4 into 10 power minus 3. 0.4, and this is my small d. 0.4 into 10 power minus 3. Divided by capital D is 2 meter. So if I substitute everything, I'll be getting what? Option C, 400 nanometer. 400 nanometer is the answer. So with this, I'm stopping the class. Okay. And any doubt is there, I'll help you out on this. Thank you.